The stars are the forges of all the materials and countless elements we have on Earth. Iron, forged in the depths of our planet's molten core, lies beneath our feet. Oxygen shapes the oceans, the rocks, and the air we breathe. Carbon forms diamonds and serves as the fundamental building block of life itself. As we learn to harness these elements and materials, we laid the foundations of our civilization upon them, with one of the key substances that played a significant role in our development: lead. A heavy metal, soft and malleable, easily shaped and formed. It is a gift from the Earth, found in its crust for millennia, waiting to be discovered and utilized. Since ancient times, civilizations have been captivated by its versatility, using it in various forms and applications. The Romans embraced its use, unaware that a hidden danger lay within this seemingly miraculous metal, a danger that would gradually unveil itself over time. Lead, though useful, carries a dark secret. It is a potent poison, capable of causing severe health issues. Its toxic nature, however, remained hidden for centuries, shrouded in mystery and ignorance. Unknowingly, humans continued to embrace it, incorporating it into their daily lives, homes, and industries, oblivious to the impending danger. The Industrial Revolution marked a turning point, a period of rapid industrialization and technological advancement. Lead production skyrocketed, its use proliferating at an unprecedented rate, becoming an integral part of modern industry. From paint to gasoline, lead became ubiquitous, infiltrating every aspect of daily life. This marked the beginning of the dark age of lead pollution. But just how toxic was this invisible enemy? Lead, a naturally occurring element, is found in the Earth's crust. Certain parts of the Earth's crust are radioactive over millions of years. These radioactive, unstable elements break down, creating lead deposits. Physicists have discovered that the atoms of unstable elements, such as uranium and thorium, decay at a consistent rate. This reliable, constant process acts as a natural clock, allowing us to determine the age of the Earth. By studying the decay of lead isotopes in ancient rocks and meteorites, researchers have been able to estimate that the Earth is approximately 4.5 billion years old. This discovery has provided invaluable insights into the formation and evolution of our planet and the solar system as a whole. But these elements are not only a cosmic clock. Lead is also mined and processed for various uses for centuries. History is replete with grim reminders of lead's devastating power. The Roman Empire, renowned for its engineering prowess, extensively utilized lead in its infrastructure. They crafted sophisticated plumbing systems with lead pipes that supplied water to their cities, baths, and homes. Lead was also used in cosmetics, adding a pale sheen to the faces of Roman women. Some historians even speculate that lead poisoning played a role in the decline of the Roman Empire. The 20th century witnessed lead's insidious creep into every facet of human life, embedding itself in the very fabric of society. Paint, prized for its durability and vibrant colors, was laced with lead, making homes and buildings vibrant yet toxic. Gasoline, fueling the burgeoning automobile industry, contained lead to enhance engine performance, ensuring smoother rides but at a hidden cost. Industries from mining to manufacturing embraced lead, releasing vast quantities into the environment, polluting air and water. Lead pipes carried water to homes, unknowingly delivering poison alongside, affecting countless families. This era of unchecked lead use marked a period of unprecedented pollution, with factories belching out toxic fumes. The air, water, and soil became saturated with this invisible threat, creating a hazardous environment. Children with their developing bodies were particularly vulnerable, suffering the most from lead exposure. But what makes lead so toxic to us? Lead is a stealthy poison. It accumulates in the body, slowly, silently wreaking havoc on organs and systems. Lead mimics the iron our bodies need, but unlike iron, it cannot fulfill our body's requirements. Instead, lead interferes with neuronal transmissions, leading to harmful effects on our health. Its effects, often subtle at first, can have devastating long-term consequences. Children bear the brunt of lead's toxicity. Their developing brains are particularly susceptible. Exposure can lead to learning disabilities, developmental delays, and reduced cognitive function. In adults, lead exposure is linked to cardiovascular disease, kidney damage, and reproductive problems. It can also cause fatigue, headaches, and irritability. Lead's most tragic impact is its irreversibility. Once the damage is done, it is often permanent. The most severe cases of lead exposure occurred among factory workers who were immersed in toxic environments filled with this hazardous substance. Workers in the industry during the 20th century suffered severe mental health effects due to lead exposure. Many experienced hallucinations and disorientation, with some tragically jumping out of windows. The consequences were dire, leading to numerous fatalities among these workers. The impact of lead pollution extends far beyond human health. The natural world, too, suffers under its toxic burden. Lead, persistent and non-biodegradable, contaminates soil and water, poisoning plants and animals. Birds, mistaking lead shot for food, suffer from lead poisoning, leading to paralysis and death. Aquatic ecosystems are particularly vulnerable. Lead accumulates in sediments, disrupting food chains and harming fish populations. The consequences of lead pollution ripple through the environment, impacting biodiversity and ecosystem health. Claire Patterson, the scientist who determined the age of the Earth by measuring uranium decay in a meteorite, also investigated the concentration of lead in both deep and shallow ocean waters. He discovered that the deep ocean contained significantly less lead. Given that the mixing of shallow and deep ocean waters typically takes a few hundred years, Patterson concluded that the elevated lead levels in the shallow ocean must be a result of recent centuries. To further his research, Patterson and his team drilled into deep ice in Antarctica to analyze lead concentrations similar to their ocean studies. They found that lead levels from centuries past were substantially lower. Patterson published a groundbreaking scientific paper challenging the lead industry, making him a target of some of the most powerful figures of his time as he fought for the health of our civilization. After 2 decades of struggle, lead was finally banned from consumer products in the United States, establishing him not only as the scientist who discovered the Earth's age, but also as a pioneer in the environmental movement. The fight against lead pollution has yielded significant victories. It took just a few years for the average lead levels in the blood of children to decrease by 75%. Today, the medical consensus is clear. There is no level of lead exposure that is deemed safe or without harmful effects. Protecting our planet, one step at a time, is a journey that requires the collective effort of every individual, community and nation. The dark age of lead pollution may be behind us, but the fight is far from over. Now we must focus on listening to scientists regarding other environmental threats. Whether it takes us 20 years or hundreds of years to recognize our damage, we can only deceive ourselves. Nature cannot be fooled. The damage we are inflicting today and the future that awaits us may be worse than the fate of the Romans.